So here's a real life example of exponential decay. And this uses what I call the PERT formula. So the amount of carbon-14 will equal the beginning amount and then E raised to the RT. So with things that change continually, we don't use the compound interest formula, but we use the E, which is saying that it's it's continually changing. My brain was trying to make that one word. Okay, notice in here there is no percent given, so the first thing we have to do is find out what R equals. So the half-life is 5,730 years, so that's what T will equal. And suppose that you start with 100 grams, so that's what the capital P is. So if I substitute the 100 right here, and then R is not known, we're going to need to solve for R. The 5730 goes right here for T. And then because it's half-life, that means that the 100 grams is going to get cut in half. So after a while, there's only going to be 50 grams. And then we need to solve for R. So what I can do is divide both sides by 100, because I'm trying to isolate that E. And then of course on the left side that equals a half, thus the half-life. And the next thing to do to solve for R is take the natural log of both sides. So the natural log and E are inverses of each other, so on the right side they're going to cancel. And then I would just have R times the 5730. And on the left side, there's still the natural log of 1/2. And then to solve for R, just divide both sides by 5730. And most likely this is going to be some small decimal. I'll need to ask the calculator. What is natural log of 1/2? So natural log of 1/2, and then that needs to be in parentheses, the 1/2. And then divide by 5730. And that is definitely a small decimal. I need to move the decimal 4 places to the left, so it's going to be negative 0.000121. So it's negative 0.000121. So I move the decimal from here 4 places to the left, and there it is in decimal form. Okay, so that means that in general, the formula is going to look like this. The amount of the carbon, what was it called? Carbon-14? The amount of carbon-14, it's going to start with 100 grams and then E to the negative 0.000121 times T. All right, what's next? So let me just clean this up a little bit. So it's saying that I'm starting with 100 grams. I already have that in the formula. And then how much? So in other words, what does A equal? If the T equals 20,000 years. So basically I just need to substitute 20,000 into this. So 100 E to the negative 0.000121 times 20,000 years. And then let's see what the calculator says. So we've got 100 and then E, and then the exponent is negative 0.000121 and times 20,000 years. And that equals about 8.892 grams. That is known as radioactive carbon dating. So if you find some ancient bones or something like that, and there is 8.892 grams left when it started with 100 grams, then the specimen is about 20,000 years old.